bit about this stuff. So the last section 3.1 just talked about like location of angles, right? We're going to take two lines, no matter what those lines look like. I don't care. They can be anything, intersecting, not intersecting, whatever. So let's say those two lines. Those are eventually going to intersect, right? So we say they're converging. But then we take this line here, which is a transversal, right? So two lines. The one that is intersecting two lines is called the transversal. When that happens, no matter what, you're always going to get 8 angles. Okay, you're going to get those 8 angles. And in section 3.1, we knew nothing about those angles in relationship to one another. Okay, all we could do is name them. And when we name them, or identify them, classify them using vocabulary, we would say like that angle there and that angle there. They're called alternate exterior angles. They're on alternate sides or different sides or opposite sides of the transversal, and they're on the exterior of the two lines that are being intersected. Okay, so we call those alternate exterior. We called like these, we called that green one and that green one alternate interior, right? Okay. We can call like that one there and that one there were corresponding. So we had that grouping of basically pairs of angles in this picture, okay? And we knew nothing about the relationships, and it's because we didn't know anything about those two lines and how those two lines related to one another. Today, we're going to take those two lines and we're going to make them parallel, okay? So these things are only said to be true if we know that the lines start off as parallel lines, okay? So we get these postulates. In some textbooks, basically what we have here is we're going to have, I think, 4 statements, 4 congruencies. This textbook uses this statement as a postulate, and then from that we can build the other 3 from it, okay, as theorems. Some textbooks use like this rule here as the postulate, and then the other 3 statements would be a theorem. So it doesn't really matter which one we identify as the postulate. I just need us to understand what is said inside the statement. Does that make sense? I don't care if you know this is a postulate or a theorem. I want you to know that when we look at same side interior angles, okay, it says if a transversal intersects 2 parallel lines. So remember with our if-then statements, that has to be happening in front of you, okay? If that is not happening, we cannot get to the conclusion, right? Does that make sense? So that has to be occurring in front of you. And in our picture, that is occurring. We've got 2 lines that are parallel, okay? Then, same side interior angles are supplementary, okay? There's an alliteration there. Same side supplementary. Okay, you guys talk about alliterations in English, right? Okay. That's going to help you remember the relationship here with certain sets of angles. Same side supplementary. But that's only if the lines are parallel. Okay? A notation that we use for lines being parallel, you see those little arrows inside the line? Okay? That's a notation to tell us that the lines are parallel. You never want to go off of looks. Okay? You want to go off of the notation that they tell you. Okay, so they'll have lines with little arrows inside them. Okay, not on the ends. But what this says, if I look at same side interior, so interior means they're going to be in the yellow. Does that make sense? That's inside the 2 lines that are being intersected by the transversal. Same side means, how do they reference in regards to the transversal? They got to be on the same side of the transversal. So we see angle 4 and angle 5 here are going to be supplementary, and angle 3 and angle 6 are going to be supplementary. And that's the conclusion that we're seeing here with this argument. Okay. Something that I think is beneficial to see, obviously it's a postulate, so we can't prove it, but we can kind of justify it with some pictures. So let me open something for us real quick. All right, so when you guys go to Schoology, if I go to geometry, obviously, chapter 3, so section 3.1 will be in 3.2. After today, I'll post the stuff here, but the red link up here, it's not linked for some reason. Okay, so the red link will be linked to section 3 or chapter 3. But this link will take you to my website homepage. This will take you to the individual section or chapter. But inside chapter 3, under 3.2, there are some interactives here that can help you make conclusions about some same-side interior angles. And if you, like, this is embedded inside my website, but if you want it out of the website and like save to your desktop, all you have to do is click on these 3 bars here, go down to where it says download as, and click over here where it says GeoGebra file, it's the top one. Name it whatever you want to, save it, it'll save to your desktop. And you can open it, make it bigger. It's easy. I think it's easier to work with inside the program instead of embedded in the website. But if I want to look at the same side interior angles, okay, I look at that set right there, okay. Notice when I do that I've got this conditionally formatted. It's an if-then statement. The way I've actually programmed this says if you, the user, click on that, then program show this little bar here. You see that pop up? Okay. And also highlighted same side interior angles. But what this bar allows you to do, if you slide it, it's going to take this angle, and you see that it slides it, and it becomes that angle, right? Does that make sense? And it didn't change size, so I'm cutting and pasting those angles. And what do you see then when it gets there? What do you notice about these 2 red angles? What kind of angles are those to one another? If I just focus on those. Supplementary, they're a linear pair, right? And we know that linear pairs are supplementary from the linear pair postulate, okay? So if that angle can be transferred to there, and these 2 are supplementary, then it must mean that back at that position, they're supplementary as well. Does that make sense to everybody? Okay. If you want to look at the other set does the same thing. Actually, I guess I don't have the slider there, so you can't see that. But if I were to take this blue one and slide it down here, or take this green one and slide it up there, we would see that we get a set of linear pairs. So same side interior angles are supplementary. I can't prove that, but hopefully this image kind of justifies that to you. Okay, and that's just moving the purple one. You could move the blue one down here and see that these 2 end up being supplementary, or these 2 form a linear pair. All right, so I'll leave that up because we're going to use that quite a bit. So what does that allow us to do? Let's say here we've got this example where we've got these 2 lines parallel. We see these red arrows in them telling us that they're parallel. It says measure of angle 3 is 55 degrees. Measure of angle 3 is 55 degrees. So I want to go through here and I want to come up with what all the other angle measurements are. If that's 55 degrees, can you tell me another angle that you know for certain? Jagger?
1.
What is 1 going to be?
55 degrees.
Why? Okay. So angle 1 and angle 3 are vertical. So those are congruent. So we got 55 degrees. What's another angle that's going to be up there? Bex?
Number 4.
Okay, what are you going to put there?
125.
Okay, so 125, because it's supplementary with what? Okay, so it's supplementary with 3, and it's supplementary with 1, right? Okay, and what I want you guys to understand is, if it's supplementary with 3, and it's got to be 125, it cannot contradict, that measurement cannot contradict it being supplementary with angle 1. Does that make sense? Okay, so that has to be matched for both of them. One more angle. Jagger?
Angle 7 is 55 degrees.
Let's not go there yet. You're right. But let's not go there yet. Let's keep focusing on this stuff over here. What's angle 2? 125. Why? Okay, so it's vertical to 4. Okay, so that's one reason. But it's also supplementary to 1 and supplementary to 3, right? So whatever approach you want to use is fine, but one of those approaches cannot contradict a truth that is established by another. Okay? Now, Jagger wanted to talk about angle 7, but how do I get to angle 7 first? What do you know about angle 2 and angle 5? Or angle 3 and angle 8? They're what? They're supplementary because of the same side postulate, right? Same side angles are supplementary. So this is going to be 55. And this would be, 125. And this would be 55 and 125, right? So we should be able to do that regardless of whatever measurement I ever give you, okay? If I give you angle, and I can start off with any one of those 8 angles. So let's say I give you angle 7 to be like 30. You should be able to go find angles 1 through 6 and angle 8 based off of that 30. Does that make sense? Okay. Now here's my question. Now that we did that with that specific case, meaning that using 55 and 125, what can you tell me about that angle right there and that angle right there? What's the relationship between their measurements? They're equal, right? Those two angles are the same amount, so those angles are congruent, right? What would we call those angles in regards to their position or their name, their vocabulary? They're exterior, okay? So they're on the outside of the two lines, and they're on what sides of the transversal? Alternate. So those would be alternate exterior angles, right? What do you think the conclusion is that we're going to say? If two lines are parallel, then alternate exterior angles are congruent. Okay, so that's going to be the next, well, eventually. I guess I had it backwards. I don't even have them in there. That's dumb. Let's go back. So that was talking about alternate exterior. What are you going to say? And we'll fix the notes here in a minute. But what are you going to say about angles 3 and 5? What kind of angles are those?
They're alternate interior.
Alternate interior. What are you going to say about angle 3 and 5's measurements? They're equal, so the angles are congruent, right? So that's what the next, okay, I got ahead of myself. That's what the next theorem talks about. It says if a transversal intersects two parallel lines, then alternate interior angles are congruent. Okay. You can also, what I would suggest right there, guys, on that slide or next to it, say that the same thing happens for alternate exterior angles. So you would say, and you write it out. If you want to write it out, you can, but it would sound, if a transversal intersects two parallel lines, then alternate exterior angles are congruent. It's the exact same phrase. Okay, just taking the exterior or the interior part out and replacing it with exterior. All right, so angle, in our particular question, angle 4 is congruent to angle 6, and angle 3 would be congruent to angle 5. Okay, now I want to prove this. Okay, we want to go through and write a 2-column proof over this. And what's going to happen, and I explained this the first time that we saw a proof in the last chapter. If you're going to prove this theorem, you need a given statement. You need something to start with. Does that make sense? Okay. Think about how we started making definitions in this class. We needed a series of terms, essentially, that we were able to kind of piece together to create new definitions, right? And those terms were points, lines, segments, rays. They were planes. They were undefined terms, right? And we can kind of stitch those together to get new definitions. Same thing happens here, okay? In order to stitch things together, I need a foundation, I need a starting point. Your starting point in every proof that you do will be the if part, okay? So in our proof, our if part is going to be our given, okay? So somehow, we're not going to write what I've got highlighted there in this box verbatim. It's not going to be word for word there because it's going to be easier to talk about parallel lines if we name them, okay? So we'll talk about specific parallel lines for our problem. The then part will be what we're trying to conclude, okay? So we'll have to talk about specific angles so that it's just easier in our proof to talk about. Does that make sense to everybody? Okay. So when we come down to this proof here, okay, it says proof of the alternate interior angles theorem. Look at the given. It says L is parallel to M. We'll go back up to that theorem we just had. Go back up to the theorem we just had where it said if a transversal intersects two parallel lines. We have two parallel lines, okay? And our picture gives us the transversal, right? Does that make sense? So that's the if part of our if-then statement. Then you had alternate interior angles congruent. Okay, that's what the actual statement was. Alternate interior angles are congruent. Are 4 and 6 a pair of alternate interior angles? Okay, so we are, with that given and that proof, we are proving the theorem, okay, with these generic representations of two lines, L and M, and the generic representation of the alternate interior angles, angles 4 and 6 here. Is that okay with everybody? All right, so let's just go through and do our two-column proof. So we have our first column is our statements column. Spell statements right. And our second column will be our reasons. All right, so first step is always given. So line L is parallel to line M. And that's given. Okay. In all the proofs that we do, okay, if there is a vocabulary word, we want to usually talk about that vocabulary word. Okay, and I'm going to say in 95% of the proofs that we do, we're going to talk about that vocabulary word. And our reason will usually be the definition of that vocabulary word. Okay? Now, parallel is a vocabulary word, so we do want to address it. But this is one of those 5% of the times that it's not because of the definition of parallel. The definition of parallel is two coplanar lines that never intersect. That's just establishing how they interact or how they're created. It doesn't give me a relationship in this problem that I can actually build off of. Okay? However, whenever you see lines that are parallel, you're going to want to start thinking about, okay, what do I know about angles that are created then? Okay? So step 2, if I know that these two lines are parallel, what did we previously say about that angle and that angle? Angles 3 and 6. They're supplementary, okay? And I like how you said that. So I'm going to write angle 3 and angle 6 are supplementary, okay? Because that's what our postulate says, okay? The same side, interior angles postulate says, and when you scroll back up to it, you can look at it in your notes, it says, if two parallel lines are cut by a transversal, then same side interior angles are supplementary, right? And I said I like the way he said that because he didn't make the jump to 180, right? Because in that postulate, there is never used the number 180. Does that make sense to everybody? Now, you all know that supplementary means 180, right? But when we're writing a proof, we're writing our proofs for people that are equally or less intelligent than us. Does that make sense? So if they're less intelligent than us and they don't know what supplementary means, but I put in that they add up to 180 right away, they're at a loss because I've skipped a step, right? Okay? If we're going through like algebra in class and I skip a step or put 2 steps together in my algebra, I can lose people doing that, right? I can confuse people, okay? It's the same idea here. If people aren't equally intelligent or are less intelligent, we can't skip steps, okay? We don't want to make the assumption that they know what supplementary means. So now that I wrote supplementary, I introduced another vocabulary word, right? So now I can actually tell everybody what does that vocabulary word mean for our particular problem. It means the measure of angle 3 plus the measure of angle 6 equals 180, right? And that's the definition of what? Supplementary angles. Okay? Whenever you introduce a vocabulary word and then you use it to make a statement, your reason will be the definition of that vocabulary word. Okay? In my videos last week, I explained if you want to write out that supplementary angles add up to 180 degrees, you can do that, and that would actually be what you would see in the glossary underneath supplementary angles, right? Jagger, you said earlier that you don't like all these writings, right? You don't want to write all this stuff down. If I had you write the actual definition and what all the postulates said, you'd be writing forever, okay? So we like to shorten that kind of stuff up by just saying definition of supplementary angles. And assuming then if somebody doesn't know what that is, so this is kind of like a roadmap for being able to show why something is the way it is, why alternate interior angles are congruent. That's what we're trying to prove. This is a roadmap to prove that. And if you get lost when you're on the road, you look at the map, right? So I'm going through here and I get lost. I'm not sure why somebody said that. Or why did they put this? Well, here's my map. Tell me, oh, go look at the definition of supplementary angles and see what that tells you. That's why they were able to say this. Okay. Now we're kind of stuck. So we've used vocabulary. We got this supplementary idea. We've exhausted all the vocabulary up here. We've exhausted all the vocabulary that we introduced. Now what we have to do is we have to look at our picture. Okay. And I'm also going to, in the back of my mind, I've got some proofs that we've already done in the past. Okay? So whenever you do a proof, it becomes kind of a part of like a Rolodex. That you guys know what a Rolodex is? Okay, so you ever seen like I'll show you what a Rolodex is. Ever seen one of these? Like it's got like facts on it, whatever you might need. It might have like telephone numbers on it, might have addresses on it or whatever. But I can scroll through it real quick and find the information I need, right? So my thought is that once I complete one proof, that it becomes part of my Rolodex. And I can now go through and use that. So what I mean by that, I'm going to go back to chapter 2.6 or section 2.6 and look at one of the proofs that we did there. So this was proving that if 2 angles are supplementary to the same angle, then the 2 angles we started with were congruent, okay? Or we could go back up to the vertical angle one, which might be a little bit easier to work with, okay? And the reason I do this is because this proof has a phrase like that in it, right? It said 2 angles were supplementary. What did we have in addition to that? We had another set of angles that were supplementary, right? So we've seen this once before, and with it came a second statement just like it. If I go down to that other one, did we have 2 angles supplementary? And then right after that have 2 more that are supplementary? So chances are when that happens, when you write a statement that includes supplementary angles, you're usually going to want another one. If you don't know what to do, see if you find another set of angles that would be supplementary. In my picture, is there another set of angles up there that would be supplementary? Four and 3? Does that make sense? Okay. Now, here's another clue if you got stuck. How do I know to use 4 and 3? Well, the textbook, the author of the textbook labeled angle 4 for a reason. If we didn't need to use it, they probably wouldn't have put a name on it. Does that make sense? So maybe that could help you kind of draw your attention to where you should look. But I'm going to write now that angle 4 and angle 3 are supplementary. Does anybody know why they're supplementary? What do they create? Straight line, right? You guys remember that says, and they're adjacent, right? So you have two angles that form a straight line. They are a linear pair, right? Okay, we had a linear pair postulate. Linear pair postulate. I think this was all the way back in section like 1.7, 1.6, something like that. Said if two adjacent angles form a straight line, they're a linear pair. Okay, that was the definition of a linear pair essentially. But then the postulate said linear pairs are supplementary. Okay, that's kind of a hard statement and reason that people struggle with initially. Okay, we'll see that enough though, that'll become kind of instinctual to you. So now that I've got 4 and 3 are supplementary in words, let's write down measure of angle 4 plus measure of angle 3 equals 180, right? Now, how did I know that? Well, we introduced a vocabulary word, didn't we? Every time that you introduce a vocab word, you need to write down what that vocab word means to you. So 3 and 4 equal 180, and our reason for that will be definition of supplementary angles. All right, so I'm going to jump back to 2.6 real quick, just to prove a point. In 2.6, when we had two phrases, two sets of angles, both adding up to 180, like I've got in that highlighted box right there. The next thing we did, because these 180s were the same, we put these yellow things equal each other, right? Okay, and that created our next statement. We did the same thing up here. When we had these two 180s the same, we set these two things equal each other, correct? So let's go back to what we're working on. Do you have, now they're not back to back, but that's fine. Is that right there and that right there, do they both incorporate 180? So if the 180s are the same, that 180 and that 180 are the same, then the yellow stuff has to be the same. Does that make sense? So measure of angle 3 plus measure of angle 6 equals measure of angle 4 plus the measure of angle 3. And all we did there, if you think about this, line 6 looks just like line 3, but I replaced 180 with what I said it was equal to in line 5. So when you replace something with what it's equal to, that's called substitution. Okay. Now, this is a pattern. So jumping back and forth between chapter 2 and this problem, trying to show you patterns, okay? Because basically this is like maybe our third or fourth like legitimate theorem that we've proven. They've all shown the same structure, the same pattern. If we had supplementary twice, we write down that it equal, those things equal 180 twice. Then we set the substitution up, and then we get two things added together equal two other things added together. And then the next step, what do we look at? Okay, well, what is on both sides of this new line? Do you see that that thing and that thing are on both sides? Now, those are numbers. They're symbols right now representing measurements. I don't know what the measurements are, but whatever the amount is, they're on both sides. So this is more of a routine type thing that some textbooks will write some will not. Some will jump straight to our conclusion. But I'm going to write this. I'm just going to tell you that measure of angle 3, that symbol on the left, is the same as measure of angle 3, the symbol on the right. And that's the reflexive property. It might not make a whole lot of sense right now, but in chapter 4 and chapter 5, when it's essential, my hope is by working it in chapter 3, it becomes kind of natural for you to use that process. If I do that, and this is the same idea, like if you had an equation, it was like 2x plus 3 equals 12. Don't most people put like minus 3 here and minus 3 there? Well, that's saying that the thing I'm about to remove is the same amount from both sides. Okay? So that's what I'm doing here. I'm saying that 3 and 3 are the same amount. And if I remove them, what are you left with? 6 being the same as 4, right? 6 is the same as 4. And that's subtraction. We remove the same amount from both sides. Now that just says that you have two angles whose degrees are the same. So then to get to the conclusion that we want, we'll actually say angle 6 is congruent to angle 4. And that reason will be definition of congruency. And in Math Excel, sometimes it'll say like angles with equal measure are congruent. That's the actual definition if we looked under congruent angles. That would be the phrase that it writes out. So now we have proven one time with generic values. Did I ever say something like this? Did I ever say like angle 6 here? Give me a number for angle 6. Say again? 4? So 4 degrees. So what would angle 3 have to be?
176.
176, because the same side interior angles have to be supplementary, right? And now what would angle 4 be? 4 degrees. What do you now recognize about angle 4 and angle 6? They're the same, right? They're congruent angles now. But that only showed it for a measurement of 4 degrees, right? How many other degrees could you have said if when I said, give me an angle measurement? You could have used an infinite number, right? And I don't know, like if I use 4.7, is that same relationship going to exist? And then I don't, okay, if it does, then I don't know if 4.71, if that relationship's going to exist. Or 4.712, okay? So you can see that there's an infinite, if I go 14.712, there's an infinite number of things that I would have to check, right? But because of this proof right here, did I specify what angle 6 had to be? Never, right? And never then specified what 3 or 4 had to be. But by using these facts, I'm able to go through the algebra and determine no matter what I start with for angle 4, angle 6 is automatically always going to be the same amount. Okay, and that's a benefit of a proof. So now, every time that I see angle 4 and angle 6, or whatever their names are, as long as they're alternate interior angles, from here on out, I can tell you that they're congruent, and you can tell me that they're congruent, and the logic or the reasoning is this right here. But we'll never have to repeat that. Does that make sense? So in another proof, if I have two angles, and we'll see this a lot, in another proof, I'll need to show that angle 4 and angle 6 are congruent. In the other proofs, I won't have to go through all this. I'll just say in the next proof, oh, 4 and 6 were alternate interior angles, and alternate interior angles are congruent, because here I've shown it to be true. Okay? So alternate interior angles are congruent, alternate exterior angles are congruent, same side interior angles are supplementary, and the last grouping of angles that we'll talk about are corresponding. And our corresponding angles, they are congruent. Okay? So we have 4 categories of angles. Alternate interior, alternate exterior, corresponding, and same side interior. All of them have the relationship, if the lines are parallel, all of them have the relationship of being congruent, except same side supplementary, right? That make sense? So if I can remember that alliteration, and that idea of the other option is to be congruent, the alliteration tells me which set's not congruent, and then the other three sets are congruent. Okay? Looking at that GeoGebra, what's nice about this, guys, with the GeoGebra, you can kind of move things around. You can make it any set of parallel lines that you ever wanted. Okay? Now you got to set it up to where you actually get an intersection, okay, or things will kind of fall apart for us. But let's say I look at maybe that set of lines, and I want to see, we already did the same side interior. Here's one set of alternate interior. And the proof that we just went through essentially did this. It took that angle and it moved it there, and then it rotates it through, and what do we see? They're congruent, right? Does that make sense? Okay. Because at that point they become vertical. Where'd it go? At that point they become vertical, and then I can rotate it through, and they match up and become congruent. Okay, so there's your other pair of alternate interior. Alternate exterior, same idea. Okay, so I move it there and they become vertical, and then I rotate it through. Yellow is kind of a bad color on my screen, but and then your corresponding, they just match straight up. So corresponding angles are congruent. There's your other set, corresponding, another set, another set. You got 4 sets of corresponding angles. So stuff makes sense? Okay, now here's my question. What has to be true about these lines? They have to be parallel. So I will ask you a question. On a test, it will look something like this. It will say, always, sometimes, what the heck was that? Always, sometimes, or never, if 2 lines are intersected by a transversal, then fill in the blank. And when I say fill in the blank, you can put alternate interior, alternate exterior, or corresponding there. One of those 3. And I ask you, is that always, sometimes, or never true? What would you tell me? That is sometimes. Okay? Because what have I failed to tell you about those 2 lines? Parallel. Okay? If I write, if 2 lines are parallel and intersected by a transversal, then alternate interior, alternate exterior, corresponding are congruent. What would you say there? If I force the lines to be parallel, they're always congruent, right? Does that make sense? So I need to tell you, remember the if part has to be satisfied by you, okay? And the if part for all of these theorems and postulates today says you have to have 2 lines that are parallel to get the conclusion of congruency or supplementary when we talked about the same side interior. Is that doable? All right. Just real quick, you're going to see a question maybe in your homework that looks something like this. Okay. What am I telling you about the top and the bottom of these 2? They're parallel, okay? We prefer to see that picture that we've dealt with so far. So what I'm going to always do is I'm going to take my parallel segments and extend them into lines. And I'm going to focus only on one transversal. Would you guys agree that this would be a transversal here? Okay, so I'm going to just redraw my picture. Now I've got obviously the technology to make things a little bit cleaner and easier for me to do this. But if I redraw my picture right there, do I still essentially have the components that made that trapezoid? Yeah. But now what kind of angles would you tell me in relation to one another are those 2 angles? Are they alternate interior? Are they alternate exterior? Are they corresponding or same side interior? Same side interior. So same side interior angles are supplementary. So 2x plus then the x minus 12 should add up to 180. And now I can solve for x, right? Can I then do the same thing by looking at this other set, hiding that stuff, looking at this? Why does it do that? Looking at this as being a transversal, are these green angles same side interior? So could I write another equation that 3y plus 20 equals 180? Does that kind of make sense to everybody? So you're going to see problems. They don't always, initially they do. Initially, a lot of your problems in your homework are going to be like that, and they put like an algebraic expression there and an algebraic expression there, and you say, oh, those are alternate exterior. They've got to be congruent, so they're equal. Okay? But then they start adding extra stuff to kind of confuse you. Okay? Try to narrow your focus to where you can generate this picture that we're accustomed to, that we're familiar with, and then it becomes so much easier. Okay? So later in your homework or your notes, there's another question like this. If I do something like this, does it make sense? Come on. To wipe those away and maybe then extend the parallel lines, extend the transversal. What does this blue angle there and that blue angle there, what kind of angles are those? Corresponding. Corresponding angles, if the lines are parallel, what's their relationship? They should be equal measurements, right? Congruent angles, so equal measurements. I'll let you guys, so in class, obviously to see more examples of the geometry, I don't necessarily always do the algebra with you, so I'll let you, if we set that up, I think we should all be at the point where we can solve those multi-step equations. But that's the structure of your homework tonight. It's going to be the structure of your homework actually in the next couple sections. So give tonight's homework a shot. Again, it's not going to be due until Wednesday, but look at that. We can ask questions about tomorrow. There are a couple other proofs in here that I want to go over tomorrow. And then if we have time, we'll get into the next section.